Hello friends, welcome to my channel. Today we're going to look at this Codility training lesson coding problem. So you are given n counters initially set to 0, and you have two possible operations on them. Increase x, which is to increase counter x by 1, or max counter, which is to set all counters to the maximum value of any counters. So there will be a non-empty array A of m integers. This array represents consecutive operations. So if A of k equals to x, and the x is in the range from 1 to n, then the operations would be increase x, which means that we increase counter at x position by 1. Otherwise, if A of k equals to n plus 1, then we'll want to apply the max counter operation, which is to set all counters to the maximum counter. So here's the example, and here's all the counters, values of the counters after each consecutive operations. Okay. So let's get to it. To solve the problem, we will have to keep tracking the maximum value of any counter, and also track the base, the base value for any counter. Okay, so but first let's create the result. So result equals to new and we're going to return result. Okay. The index for the result is going from 0 to n minus 1, which is 1 off from the range of x, which is from 1 to n. So we're going to have to be careful about this point. Okay, so next we're going to go over the operations. Okay, so A from A, so this would be operations, and we will see the value of A and see if A equals to n plus 1. Okay, because if A equals to n plus 1, then we want to apply max counter. Otherwise, if A is greater than or equal to 1, and A is smaller than or equals to n, then we want to apply increase x. But for each iteration of operation A, array A, we want to track the max. Okay. How do we track the max? So let's say max is 0. Okay, we initialize max to 0, and we initialize the base to 0. Okay. And so whenever that we had to increase the apply max counter, then all we need to do is to set base to max. Otherwise, if we want to increase a counter, we would look at the value of the counter first. Okay, so if the value of the counter. What's the value of the counter then? Okay, so that should be resolved. If the value of the counter, which is a, so a is going from 1 to n, so we have to minus 1, is smaller than the base, we're going to have to first elevate its value to base and then increase its value by 1. And after that, we will have to go over all the results. Oh, we still have to track the maximum. Okay, so max would equals to max and the max result a minus 1. And so after the for loop, we still have to track to see if any value is below the base. If any value is below the base, which means that that value, that counter, if any counter is below the base, if that counter is below the base, which means that this counter has never been operated. So in which case we just simply elevate its value to be base. So we're going to go I less than result length I increase. Okay. So if that is okay, so that is if result I is less than base, we're going to assign base to it. Okay, so let's run the code, see what happens. Okay, so we got the result. Let's look at the time complexity. So we created an array. We call it result. So that would be the space complexity would be big of n because we create an array of n. So this is a capital letter N. And then for each element in A, okay, so so we have this for loop which is looping through all the elements, and then this is again looping all the elements from result. Okay, so if we define n little n to be the length of A, then we have spent big O of lowercase n time complexity for this for loop, and then the time complexity of capital letter N for this for loop. So the time complexity would be the time complexity whichever one is larger. Okay, so time complexity would be big O of max n or n. Okay, whichever is larger. Okay, let's check for correctness, performance. Yeah, so submit your test are ready. Yeah. A 100%. Well, thanks very much for watching, and you have a nice day.